We're going to talk about conjugate acid and base pairing. So whenever you have something that's an acid, that's going to give away a hydrogen ion. And if you have a base, that's something that accepts a hydrogen ion. So these are all examples of an acid or a base being put in water. And water is amphoteric, which means it can act as either an acid or a base, depending on what it's paired up with. So in the first example we have here, hydrochloric acid being put in water. So what water is going to do in this case is it's going to absorb a hydrogen to become H3O+. So since it gained a hydrogen, it's acting as a base. And the hydrochloric acid gives away a hydrogen, which means it's acting as an acid. But once those processes occur and the products are formed, what you have is the acid becomes now something that's able to accept a hydrogen, which is its conjugate base. The water went from being water to an acid, because now it's capable of giving away a hydrogen. So an acid will become its conjugate base, and by definition the conjugate base is what's left of an acid after it donates a proton. The base will become its conjugate acid, because it becomes an acid once it gains a proton. So this is the pairing that occurs. Now this right here is an example of a strong acid dissolving in water, which is a weak base, obviously. So you have a strong acid, it's going to push and completely ionize, and so all of the materials would be in the product form. So you're going to have a one-way arrow here, meaning that all of the reactants will get converted to products when the reaction occurs. The next one is an example of acetic acid, which is in vinegar, and that's a weak acid. So still an acid, still gives away a hydrogen, but really it doesn't do it all the time. So what we end up with is a double arrow indicating we have an equilibrium situation. So since it's a weak acid, you're going to end up with an equilibrium arrow. If it's a strong acid, you're going to end up with a one-way arrow. All right, so only products will form. And in fact, the conjugate base here is actually relatively strong, meaning that most of the material, this is going to be capable of removing a hydrogen from water, the hydronium ion rather, and pushing back towards the formation of this. The next example is one of a weak base. Now, you need to memorize the list of strong acids and strong bases. Everything else you can consider to be weak. So when you have this weak base right here, and you put it in water, it's capable of pulling a hydrogen off water, meaning it acts as a base. And since the water gives away a hydrogen in this case, it's acting as an acid. So again, since it's weak, you're going to end up with an equilibrium arrow, because it's only going to dissociate a small portion of the time. And most of the time, it's going to get pushed back towards the reactant side.